Hello everyone. Today we have to solve problems on partial fractions. Type number 1. When denominator contains non-repeated linear factors in given rational function. And that rational function we are assuming proper rational function to find its partial fractions. So first of all, sum number 1 resolve into partial fractions. This is rational function 1 upon x square minus 1, and this sum is appeared for 2 marks. Let us solve this sum. First of all, given rational function 1 upon x square minus 1 is equal to, we can write x minus 1 into x plus 1, and here we are using formula a square minus b square is equal to a minus b into a plus b. Applying this formula, x square minus 1 we can express like this, x minus 1 into x plus 1. Now we have to represent this like this, a upon first linear factor, that is x minus 1, plus b upon second linear factor, that is x plus 1. Okay, and left hand side is this one, 1 upon x minus 1 into x plus 1. Okay, so taking LCM on right hand side, we can write LCM of right hand side will be denominator of left hand side, x minus 1 into x plus 1. Now this denominator we have to divide by denominator of first term, x minus 1 into x plus 1 divided by x minus 1. X minus 1 get cancels with this x minus 1, remains only x plus 1. So a into x plus 1 plus, now x plus 1 and this x plus 1 gets cancelled, remains x minus 1 here. So b into x minus 1. This is RHS and this is LHS. Denominators of RHS and LHS are same. So numerators must be equal. Hence we can write numerator of left hand side is 1 is equal to numerator of right hand side is a into x plus 1 plus b into x minus 1. Consider this is equation number 1. Now we have to find out values of arbitrary constants a and b. Okay, now here to find value of a, denominator of first term is x minus 1. Equate x minus 1 to 0. X minus 1 is equal to 0. This implies x is equal to 1, and this x is equal to 1 we have to put in equation number 1. Okay, hence we can write 2a is equal to 1. Taking this 2 on right hand side, a is equal to 1 upon 2, and this is value of constant a. Let us find value of constant b. To find value of constant b, denominator is x plus 1 here. Okay, equate this denominator to 0. X plus 1 is equal to 0. Hence x is equal to minus 1. And put this in equation number 1. So we can write here minus 2b is equal to 1. Hence b is equal to minus 1 upon 2. These are values of arbitrary constants a and b. Put the values of arbitrary constants in this equation, means partial fractions of given rational function given by 1 upon x square minus 1 is equal to a is half 1 upon 2 divided by x minus 1 plus minus 1 upon 2 divided by x plus 1. And these are partial fractions of given rational function, which is solution. Let us solve example number 2. Resolve into partial fractions x plus 5 divided by x square minus x. This sum is also appeared for 2 marks. Let us solve this. Given rational function x plus 5 divided by x square minus x. From denominator we can take x common. So this can be written as x plus 5 divided by x into bracket x minus 1. So these two are linear polynomials and which are non-repeated. Now we have to express this in the form of a is constant divided by first linear factor, that is x, plus b divided by second linear factor, that is x minus 1. Okay, so taking LCM of right hand side, LCM will be denominator of left hand side, that is x into x minus 1. X and this x gets cancelled, remains x minus 1, a into x minus 1 plus b into x minus 1 cancels with this x minus 1, b into x. Now denominator of left hand side is equal to denominator of right hand side. Hence we can say x plus 5 is equal to a into x minus 1 plus b into x. Means numerators must be equal. Hence we can write x plus 5 is equal to a into x minus 1 plus bx. You can consider this as equation number 1 and consider this as equation number 2. Okay. Now to find value of arbitrary constant a, its denominator is x, equate denominator to 0. Put x is equal to 0 in 2 here. Hence we can write 0 plus 5 is equal to a into 0 minus 1 plus b into 0, that is 0. Hence 5 is equal to minus a. Hence a is equal to minus 5. This is the value of constant a. Let us find value of constant b. Put denominator of b is x minus 1. X minus 1 is equal to 0 in equation number 2. Okay, meaning of this is what? We have to substitute x is equal to 1 in equation number 2. Hence, replacing x by 1 on left hand side, 1 plus 5 is equal to a into, this becomes 0 plus b into 1. Means 6 is equal to b. Hence, b is equal to 6 and values of these constants we have to put in equation number 1. Hence we can write x plus 5 divided by x square minus x is equal to a upon x, a is minus 5 divided by x, plus b upon x minus 1, b is 6, 6 upon x minus 1. And this is answer. Let us solve sum number 3. Resolve into partial fractions. Rational function is given like this: 1 upon x cube plus 3x square plus 2x. This sum is also appeared for 2 marks. To solve this sum, from denominator in each term there is x and smallest power of x is 1. You can take x common from each term. Okay. So given rational function we can write 1 upon x cube plus 3x square plus 2x, and now we are taking x common from each term, then into bracket remains x cube divided by x, that is x square, plus 3x square divided by x, 3x, plus 2x divided by this x, 2. Okay, then this is equal to, we can write, this is quadratic factor, coefficient of x square is 1 and constant term is 2. Okay, so 1 into 2, this is equal to 2. We have to find out factors of these two, so that addition of that factors will be plus 3, and that factors are plus 2 plus 1. These are factors. So we can write this as x plus 2, one linear factor, and x plus 1, another linear factor. So x into x plus 1 into x plus 2. Okay, so arbitrary constant a divided by first linear factor plus arbitrary constant b divided by second linear factor plus arbitrary constant c divided by third linear factor, that is x plus 2. Now make the denominator of right hand side is equal to denominator of left hand side. Means we are taking LCM of denominators of right hand side. So that will be x into x plus 1 into x plus 2. Okay. Now this x gets cancelled with this x. So a into x plus 1 into x plus 2 plus this plus b into x plus 1 get cancelled with this x plus 1 remains x into x plus 2. X into x plus 2 plus c into x plus 2 gets cancels with this x into x plus 1 into c. X into x plus 1. Okay. Now here denominators of right hand side and left hand side are equal. Hence numerators must be equal. So we can write 1 is equal to numerator of right hand side is a into x plus 1 into x plus 2 plus b into x plus 2 plus c into x plus 1. Okay. And now consider this as equation number 2. Now to find a, denominator of a is x, equate x to 0 and put this in equation number 2. Okay. So equation number 2 becomes left hand side of equation 2 is 1 and right hand side a into x plus 1. X we are replacing by 0. 0 plus 1 into 0 plus 2 plus b into x plus 2. X is 0, so this term becomes 0 plus c into x plus 1. So third term also becomes 0. Hence 1 is equal to a into 0 plus 1 is 1, 1 into 2, 2a. Hence a is equal to, taking this 2 on left hand side, 1 upon 2. This is value of constant a. Let us find value of b. To find value of b, denominator of b is x plus 1. Equate x plus 1 to 0, that is x is equal to minus 1. This value we have to put in equation number 2. Left hand side is 1, 1 is equal to, now right hand side a into x plus 1 into x plus 2. Okay, and we are replacing x by minus 1. So first term becomes 0 plus second term b into x plus 2, but x is minus 1. Minus 1 into minus 1 plus 2. And third term is c into x plus 1. Means third term also becomes 0. And then b is equal to minus 1. This is value of constant b. Now to find value of c, denominator of c is x plus 2. Put x plus 2 is equal to 0. That means x is equal to minus 2. We have to put this in equation 2. Okay. Left hand side as it is. On right hand side, if we substitute x is equal to minus 2, first term becomes 0. Second term also becomes 0. And in third term, c into minus 2 into minus 2 plus 1. And simplify this, 1 is equal to 2c. And this implies c is equal to 1 upon 2. This is value of constant c. Now put the values of a, b, c in equation number 1. Hence given rational function is 1 upon x cube plus 3x square plus 2x, and its partial fractions. A is half divided by x plus b is minus 1 divided by x plus 1 plus c is half divided by x plus 2, and this is answer. Okay, let us solve next sum. Sum number 4. Find partial fractions of this rational function 1 upon x cube minus x. This sum is also gives 2 marks. Okay, so to solve this sum, rational function 1 upon x cube minus x. From both the terms we can take x common. 1 upon x into bracket remains x cube divided by x, that gives x square, and minus sign x divided by x, that becomes 1. Okay, and this is equal to 1 upon x into x square minus 1, that is applying formula a square minus b square, which is equal to a minus b into a plus b. So x square minus 1 can be written as x minus 1 into x plus 1. Okay, now this is equal to, in terms of arbitrary constants, arbitrary constant a divided by first linear factor is x plus arbitrary constant b divided by second linear factor x minus 1 plus arbitrary constant c divided by third linear factor, that is x plus 1. Now LCM of denominators of right hand sides, that is equal to, we have to consider denominator of left hand side, which is x into x minus 1 into x plus 1. Okay. Now x gets cancels with this x. In numerator, a into x minus 1 into x plus 1 plus b into x plus 1. X plus 1 gets cancels with this x plus 1, remains x into x minus 1. So plus c into x into x minus 1. Denominator of left hand side and denominator of right hand side both are same. Hence, we can equate numerators. So we can write here, suppose this is equation number 1. 1 is equal to a into x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1, and consider this is equation number 2. Okay. Now using equation number 2, we have to find out values of arbitrary constants a, b and c. To find value of a, here denominator of a is x, equate x to 0 and put in equation number 2. Okay. So x is 0 means this term becomes 0 and this term becomes 0. There remains only this term. So 1 is equal to a into 0 minus 1 into 0 plus 1 plus b into 0 into something, that is 0, plus c into 0 into something, that is 0. From here, minus 1 into 1. 1 is equal to a into minus 1 into 1. So a is equal to minus 1, and now we have to find out value of arbitrary constant b, and denominator of b is x minus 1. Equate x minus 1 with 0, that is x is equal to 1. We have to put this in equation number 2. Okay. This term becomes 0 and this term becomes 0. Remains only second term. Hence 1 is equal to 0 plus b into 1 into 1 plus 1 plus 0. 1 plus 1 is 2. 2 into 1, 2. 2 into b. 1 is equal to 2b. And this implies b is equal to, taking this 2 on left hand side, 1 upon 2. This is the value of arbitrary constant b. To find the value of arbitrary constant c, you know denominator of c is x plus 1. So to find c, we have to equate x plus 1 with 0. Means x is equal to minus 1. We have to put this in equation number 2. And if we substitute x is equal to minus 1 in equation number 2, you can check this term becomes 0. Minus 1 plus 1, 0. This term also becomes 0. Remains only this term. So we can write left hand side 1 is equal to 0 plus 0 plus c into minus 1 into minus 1 minus 1. Okay. And then simplify this. After simplification, left hand side is 1. On right hand side, minus 1 into minus 1 minus 1 minus 2. Minus 2 into minus 1 is 2. 2c. Hence, c is equal to, taking this 2 on left hand side, 1 upon 2. This is value of third arbitrary constant c. Now put the values of arbitrary constants a, b and c in equation number 1. Hence, partial fractions of given rational function given by 1 upon x cube minus x is equal to a upon x. A is minus 1. Minus 1 upon x plus b upon x minus 1, but value of b is half, plus half divided by x minus 1, plus c is also half divided by x plus 1. And this is solution of given sum. These are partial fractions of given rational function. Let us solve example number 5. Find partial fractions of this rational function 8x minus 4 divided by 3x square minus 2x minus 1. Denominator is a quadratic factor. Okay. We have to find out linear factors of this quadratic factor. So to solve this sum, given rational function, we can write 8x minus 4 divided by 3x square minus 2x minus 1. Coefficient of x square is 3 and constant term is 1. Okay, take multiplication of 3 and 1. 3 into 1 is equal to 3. Now find the factors of 3 such that their subtraction, due to this minus sign, their subtraction will be minus 2. And here we can write 3 1 ja 3. Okay, so that factors will be 3 and 1 such that sign of 3 will be minus and sign of 1 will be plus. So minus 3 plus 1. This gives factors, linear factors of this polynomial. So this is equal to, we can write, let us put here numerator as it is, denominator we can write 3x square minus 2x, we can write minus 3x plus 1x, and this minus 1. Okay, now first two terms you can take 3x common, and from these two terms you can take 1 common. Hence this is equal to 8x minus 4 divided by, taking 3x common we can write into bracket x minus 1, and from these two terms you can take plus 1 common, into bracket remains x minus 1. Okay, now from here, in first term this bracket x minus 1, in second term this bracket, you can take this bracket common, and then this rational function becomes 8x minus 4 divided by x minus 1, this bracket we are taking common. In another bracket remains 3x plus 1. Now you can check here, these are linear factors of denominator. X minus 1, this is one linear factor, 3x plus 1 is. Now you have to express this arbitrary constant a divided by first linear factor plus arbitrary constant b divided by second linear factor. Okay, now LCM of right hand side, that will be denominator of left hand side, x minus 1 into 3x plus 1. X minus 1 gets cancelled with this, remains this factor. So a into 3x plus 1 plus b into 3x plus 1 gets cancelled with this, remains x minus 1, b into x minus 1. This is equation number 1, suppose. Now here denominators are equal, hence numerators must be equal. On left hand side numerator is 8x minus 4, and on right hand side numerator is this one, a into 3x plus 1 plus b into x minus 1. Okay, and consider this is equation number 2. Now to find value of constant a, denominator of a is x minus 1. Put x minus 1 is equal to 0, that is nothing but x is equal to 1. Put in 2. Okay, 8 into 1 minus 4 left hand side, which is equal to, now right hand side, a into 3 into 1 plus 1, and second term 0. So 4 is equal to 4a, and hence value of a is 1. To get the value of b, you know denominator of b is 3x plus 1. So 3x plus 1 we have to equate it to 0. Then x is equal to minus 1 upon 3. This is fraction. Okay, so instead of this value we can put value of x other than 1, and that value will be very small value in this equation. As well as we have to put the value of a also in this equation, that gives value of b. So put x is equal to 0 and a is equal to this value 1 in equation 2. 8 into 0 minus 4 is equal to, value of a is 1, 1 into 3 into 0 plus 1 plus b into 0 minus 1. So 8 into 0 is 0, left hand side minus 4 only, this is equal to 3 into 0 is 0, 0 plus 1 is 1, 1 into 1, 1 plus b into minus 1 minus b. Take this one on this side, so we can write b is equal to 4 plus 1, 5. This is value of constant b. And now put the values of a and b in equation 1. Hence partial fractions of given rational function 8x minus 4 divided by 3x square minus 2x minus 1 is equal to a upon x minus 1. A is 1. 1 upon x minus 1 plus b is 5. 5 upon 3x plus 1. Okay, and this is solution of given sum, which is answer. Let us solve sum number 6. Resolve into partial fractions. Given rational function is sin theta plus 1 divided by first bracket sin theta plus 2 and second bracket sin theta plus 3. Okay, to solve this sum, first of all we have to assume sin theta is equal to x. So given rational function becomes sin theta plus 1 divided by sin theta plus 2 in another bracket sin theta plus 3. This is equal to x plus 1 divided by x plus 2 into x plus 3. Okay, and now denominator contains two linear factors. First one is x plus 2, second one is x plus 3. So this is equal to, we can express like this, a upon first linear factor plus constant b upon second linear factor. And now denominator of right hand side, that will be denominator of left hand side. That is nothing but LCM of right hand side, x plus 2 into x plus 3. So x plus 2 gets cancelled with this x plus 2, remains x plus 3. A into x plus 3 plus b into x plus 3 gets cancelled with this x plus 3, remains x plus 2. So b into x plus 2. Hence, now denominator of left hand side is equal to denominator of right hand side, and there is equal to sign in between LHS and RHS. So numerators must be equal. Applying the property, we can equate numerators. X plus 1 is equal to a into x plus 3 plus b into x plus 2. And consider this is equation number 2. This is equation number 1. Now we have to find out values of constants a and b. To find the value of a, denominator of a is x plus 2. Equate x plus 2 to 0, means x is equal to minus 2. We have to put this value in equation 2. On left hand side, minus 2 plus 1 is equal to a into bracket x is replaced by minus 2 plus this 3 and plus b into minus 2 plus 2. This minus 2 plus 2 is 0. 0 into something is 0. This becomes 0. And now minus 2 plus 1 is minus 1. And minus 2 plus 3 is 1. 1 is equal to a. Hence a is equal to minus 1. This is value of first constant. To find value of second constant, its denominator is x plus 3. We have to equate x plus 3 to 0. X plus 3 is equal to 0. Meaning of this, x is equal to minus 3. And we have to put this value of x in equation number 2. So minus 3 plus 1 is equal to a into minus 3 plus 3 plus b into minus 3 plus 2. Okay, minus 3 plus 1, that is nothing but minus 2. Left hand side becomes minus 2. On right hand side, minus 3 plus 3, which is 0. 0 into something, that is 0. Minus 3 plus 2 is minus 1. So minus 1 into b is minus b. Okay, hence this implies b is equal to 2. These are values of constants a and b. Now put these values in equation number 1. Hence we can write sin x plus 1 divided by x plus 2 into x plus 3 is equal to a upon x plus 2. A is minus 1, minus 1 upon x plus 2 plus b upon x plus 3. B is 2, 2 upon x plus 3. Okay, since our assumption x is equal to sin theta. Sin theta plus 1 divided by sin theta plus 2 in another bracket sin theta plus 3. This is equal to minus 1 upon sin theta plus 2 plus 2 upon sin theta plus 3. Okay, these are partial fractions of given rational function. This is solution of given sum. Let us stop here. Thank you. Thank you all. Thank you for watching this video. Thanks.